Alright guys, now that you've tried these on your own, I want to take a look with you. We're going to be writing the equation of a circle on this first couple of examples. And we're given the center, and we're given its radius. So we know that that radius squared should equal the difference in the x value, so x minus our negative 5, quantity squared, plus, for our y values, y minus 0. We want to go ahead and simplify these. So 4.8 squared is going to give us a 23.04 is equal to our x plus 5 quantity squared, and y minus 0 we can go ahead and just call that y squared. So there's our equation of our circle. For the next one, we know that that radius squared should equal the difference in the x value, so x minus a 2 quantity squared plus a y minus an 8 quantity squared. The only thing to simplify here is 7 squared we know is 49, so 49 is equal to x minus 2 quantity squared plus our y minus 8 quantity squared. Now, for the next one, we're told that we have the point that is on the circle, and we know its center. We're going to write the equation of the circle. Now this one's a little bit different because we don't know the radius, but we do know a point that's on the circle. So to write an equation of a circle, we need to first find that radius. The radius, we can use that distance formula to find the difference in the x value squared and the difference in the y value squared using that distance formula to get there. We know that the radius is the distance between the point that's on the circle and its center. So to get our radius, we're going to take the square root of the difference in the x values squared plus the difference in the y values squared. So this radius will be the square root of, we're going to have a 2 squared plus a negative 4 squared. Our 2 squared would be a 4. And our negative 4 squared would be a 16. So this radius is a radical 20. To write our equation, we need the radius and we need the center point, which we have both of those now. So we could say that that radius squared, so the radical 20 squared, which is the nice thing here, the square and the square root will cancel each other out, will equal our x minus the x value squared plus y minus that y value. And minus a negative 3, be careful, that will be plus 3 quantity squared. And again, we won't want to leave this as a radical 20 squared. We'll say 20 is equal to our x minus 4 quantity squared plus the y plus 3 quantity squared. And there's our equation of our circle. So we need those parts. We need the radius and we need the center to be able to write our equation. On this next problem, notice that we're supposed to graph it. And in order to graph it, we need to know those pieces of information. We need to know the center, and we need to know the radius. But we can find those things just by looking at this equation. We know the ordered pair for the center of that circle. This was x minus the x value and y minus the y value. So it's the opposite of each one of these values will make our center. So a negative 2, 3 would be the center of that circle. So we need to take the square root to get back to our radius. So the square root of 9, this has a radius of 3. To plot this one, it's not going to necessarily be super beautiful. You're going to laugh at mine probably in a minute. Our center was at negative 2, 3. That's our center. The radius was 3. So I count out 3 in the directions that are all horizontal and vertical that we can count out 3 pretty nicely to be able to see, okay, these are kind of the boundaries of my circle. And from there, draw the best circle that you can. Know that it's not going to be perfect. You know mine is not. Hey, that wasn't too terrible, but there's our graph of our circle. This next one is another example of graphing a circle. We've been given the equation, so we can come up with the center, and we can come up with the radius. The center, again, is always going to be the opposite of each one of these values because it was x minus the x value of that origin, or of that center. It was x minus the x value of that center and y minus the y value of that center. So we should have a positive 3 and a negative 1 on this one for our center. The radius is always the square root of that last number because we know it's radius squared in the formula. So the square root of 4 would be 2. So if my center is at 3 comma negative 1 and I want to move 2 in each direction, so 2 horizontally and vertically, where I can easily plot those 2 units, then we can draw our circle in from there. For this last example, they've given us the equation, so we could go ahead and graph that circle, and then they ask us where each of these different ordered pairs would be located, inside, outside, or on the circle. So let's go ahead and let's first graph our circle. Its center would be at positive 7 and positive 6, again because we're doing those opposites, and the radius, the square root of 9, would be 3. So as we start to plot our circle, at 7 comma 6, that should be the center of my circle, and I want to go 3 in each direction for my radius. So I'm going to go ahead and do my best attempt again at drawing a circle. Alright, not too bad. Alright, now, if you take a look at these points, the point 5 comma 6 is clearly inside the circle. I don't have to even rely on my drawing abilities to determine that because we know that it's on the radius that I kind of made to draw my circle. So because it's inside of that radius, it's not out the full 3 units, this point would be considered inside the circle. If I take a look at the next point was 4 comma 7, so 4 up 7. I know that that point cannot be truly on the circle because this point was on the circle, so it should be curving in somewhere around there. So this point of 4 comma 7 should be outside. It's close, but it's outside the circle. Now, 3 comma 10. If I look at 3 comma 10, we shouldn't really have much guessing to do on that one. That is definitely outside the circle. And then our last one, the point 7 comma 3, because when we were extending our radius to really help us to draw that circle, we know that that is a point that is on the circle. So 7, 3, we would say it's located on the circle.